Hello everyone. I hope you all are doing well. Welcome to the lecture series of machine learning. In this lecture, we will see shifting from traditional programming to machine learning. We will understand how traditional programming works and how we shift from traditional programming to machine learning. We will discuss this in detail in this lecture. Traditional programming means giving rules and instructions to a computer. We have to write all the instructions literally, step by step, in a proper sequence, and this is called traditional programming. While machine learning means that once we train a machine, it can learn from the data by itself. Here, we do not need to write all the rules. We simply provide data to the machine. Once the machine has enough data, it learns patterns from that data by itself. We do not have to provide every single rule here. This is called machine learning. Let us understand this with an example. Imagine you're in a school, you are a most senior student, and you are also head of students. Every morning, you have a task. Uh, every day, every morning, you have a task. You have to stand near the main gate, and students from different standards will come to school, and from first standard to 12th standard, of course, they'll enter the school, and your task is to stand at the main gate and check whether every student is carrying a school bag or not. So this is your task. Now, every morning you stand at the school gate, and students from the different standards keep coming into the school, and you check whether the bag they are carrying is a school bag or not. And daily you check so many bags every day, and that you become tired. And this is because doing the same task, of course, this is because doing the same task every day, and it is time consuming and boring as well, right? So you think that every day I have to check whether this is a school bag or not. Why don't I create a machine that can check it automatically? Wouldn't it that be great? Now you have to decide, should you build this system using the traditional programming or a machine learning? Then you think that okay, let's try both. First, you thought that first let's try traditional programming, and in traditional programming, you give the computer instructions one by one. You literally tell the computer things like if the color is like this or the is like that, if the shape is like that, if the weight is like that, and so on. You give the machine many such instructions, and if all the conditions are satisfied, the machine decides that okay, it is a school bag. It is otherwise it decides that it is not a school bag. This is how we give instructions to a machine using traditional programming. Now on the other side, we have machine learning. So you thought that okay, let's try machine learning. Here you give your model many images of school bags. And also some are just bags, not school bags. And this way you provide data to this model. That's it. You did not give it a hundred of individual rules, right? You simply provide a large amount of data. This is how we train both the you train both the systems. Now let's test the machine. The next morning, a student comes to the school. The student has a transparent bag. The bag also has many badges on it, and it has only one strap. In traditional programming, you did not give instructions for a bag that is transparent, has badges, and has only one strap, right? So, because you did not provide the specific instructions, the traditional system may get confused and may not give the correct answer. But on the other side, in machine learning, you did not provide you provided many different images of bags during the training, right? So the machine learns the pattern from those examples, and so it can understand that yes, this is a school bag, and you get the correct result. Now let's understand that how machine learning was able to identify that it was a school bag. Actually, we gave the machine thousands of images of different bags, and we trained it using all this data. And now, what does it mean to train machine? Let's understand that. Training a machine means that along with the data, we also provide a label. For example, as you can see on the screen, we give the machine six images. If an image shows a school bag, we label it as a yes. And if it is not a school bag, we label it as no. So the machine learns from examples like this is a school bag and this is not a school bag. So when we provide data together with its label, we call it training data set, and this is how we can train a machine. Now let's understand the workflow of machine learning. How does the machine learn and finally identify that something is a school bag or not? First, we train the machine with very large amount of data. We provide millions of data points to the machine. After that, we take some new data and test the machine. We ask the machine that I have provided you with so much data during training. Based on that data, tell me whether this new bag is a school bag or not. If the machine gives an answer, we then check its performance. One way to measure performance is through accuracy. There are various scores like accuracy. You may not understand performance and accuracy clearly right now. So let's talk about one simple example. Suppose your maths teacher gives you 10 problems in class. The teacher tells you questions like this may come in the exam, and you practice those 10 problems. Now you take the test. Suppose some of the same questions appear in the test, your performance will probably be very good, right? And sorry, you give the test. Suppose some of the same questions appear in the test, your performance will probably be very good. Your accuracy may even be 100% because you get all the answers correct. Now let's take another situation. Your teacher gives you 10 problems to practice, but in the test you get completely new problems. You have never seen those exact problems before. Now you have to use what you learned from those 10 problems to solve the new ones. Just like machine was not trained for the pink transparent badges and one strap bag, but it learned from the data which was provided as a training, right? So uh, you have to use what you learned from those 10 problems to solve the new ones, and your performance is checked again. You may know how to solve them or you may not know, right? So your percentage may be lower or very. So machine learning works in a similar way. First, we train the machine, then we test the machine, and finally we check its performance. Actually, there are different scores that can be used to measure performance. One of them is accuracy. This is how the basic machine learning workflow works. Now let's understand how a machine actually learns with another example from our daily life. Imagine a small child, or imagine yourself. When we were young, we did not know what an apple was, right? So when we learned about apple, did people tell us the apple should have this exact shape, it should have this exact size, it should have this exact color and exact weight, so and so weight? No, no, right? Nobody gave us all these parameters. Instead, we saw, actually, they saw us, showed us many different examples, images of apples, and we saw apples in different shapes and sizes, and also we touched them and experienced them, and slowly we learned that okay, this is an apple. Correct. So after seeing enough examples, the child recognizes a new apple instantly. Machines also learn in a similar way. We give the machines many different images of apples, and from these examples the machine learns that okay, this is what an apple looks like. We do not manually give it the weight, color, shape and all the other parameters. We simply provide many images, and this is how machine learning works. Now let's look at some real life examples related to technology. Spam emails are very good examples of machine learning. First, we train the machine using a large number of emails. We also provide labels. For example, we tell the machine an email like this is a spam, an email like this is not spam. And when we say email like this, and means some specific words, if some words are used in the email, means it can be spam, and if it is a spam or it is not a spam. So we train the machine with many such examples, and then when a new email arrives, the machine can automatically decide whether it should be classified as spam or not. This is an example of classification using machine learning. We will learn about the classification in upcoming lectures. So let's take another example of Netflix. When you use Netflix, you may search for particular movies or series. The algorithm behind the system learns from your activity. It can understand that you are interested in certain types of category of movies and shows, and so the next time you open Netflix, it suggests similar movies and shows to you, and we call this is actually a recommendation system. This is also an example of machine learning. The system learns from data such as what you search for and what you watch, and then give you recommendations. Another very interesting example is of a face recognition. We see this in mostly in CCTV cameras and other systems. Suppose there are many people and many objects in a place, and the system can identify human faces among all these objects. It can focus on the human face and identify a particular person. So how is this possible, right? So the system has been trained using a large amount of data containing human faces, and based on the patterns it has learned, it can identify new faces as well. So these are just few examples related to technology, and here we can say that from writing rules to learning from data is what machine learning is all about. And this example and this simple idea has transformed almost every modern technology we used today. Now, let me ask you a question. If you wanted to teach a computer to identify ripe and unripe mangoes, would you write hundreds of rules, or would you show it thousands of example pictures? What would you do? I will give you 10 seconds. Think about it and tell me your answer. Okay, your time up. Okay, so I know your answer is definitely show it thousands of example pictures, right? And that is 100% correct. Because think about it. If you wanted to teach a computer to identify whether a mango is ripe or unripe using traditional programming, you would have to write so many instructions, and you would need so many lines of code, right? It would not be practical at all. So there can be so many different because there can be so many different combinations and variations of this ripe and unripe mangoes. So a ripe mango can look different from another ripe mango. An unripe mango can also look very different from another unripe mango. So instead of writing hundreds or thousands of rules, we can use machine learning model. We give them we give the model many pictures of ripe and unripe mangoes, and along with, of course, along with pictures, we also provide the labels, right? This is a ripe mango and this is unripe mango, and that is the basic concept of machine learning. And now you understood that why we shifted from traditional programming to machine learning. Okay, so we will see you in the next lecture video. Till then, bye bye, take care.